On this channel, we provide useful programming information with practical code examples. This time, it's about file operations in Python. With safety, efficiency, and readability in mind, this guide explains concepts step by step, from basics to practical techniques. Enabling subtitles will make the code descriptions easier to understand. File operations are an essential fundamental skill, from small scripts to large-scale applications. First, let's look at examples of reading and writing text files. Using the with statement, Context Manager ensures the file is properly closed. The following code opens a text file, reads its contents, and processes them line by line. Explicitly specifying encoding equals UTF-8 helps reduce platform-dependent issues. Even with large files, for line in F is memory efficient. Pay attention to the mode when writing to files. W is for overwriting, A is for appending. Use the with statement when writing as well. The following code shows basic examples of overwriting and appending. This code writes text to output.txt and then appends more text to the same file. The W mode overwrites the file, while A mode appends a new line to the end of the existing content. If you need to flush, call flush, but usually the content is flushed automatically when the context ends. If multiple processes or threads may write at the same time, you need to consider exclusive control, such as file locking. Images and compressed files are handled in binary mode, RB, or WB. Unlike text mode, encoding is ignored. The following code reads a binary file and copies it to another file in binary mode. When handling large binaries, avoid reading everything at once with read. Reading and writing in chunks is more memory efficient. For huge files that don't fit into memory, read and write them in fixed-size chunks. Since it's I/O bound, adjusting the buffer size is useful. The following code copies a file in 64 kilobytes chunks. This operates quickly while keeping memory usage low. You can adjust the chunk size according to the characteristics of your network or disk. On SSDs, a slightly larger chunk size often works better. By specifying the buffering argument in the open function, you can control the buffer size used internally by Python. This allows you to further optimize input-output efficiency. If you set the value of buffering to 0, I/O is performed without buffering. 1 enables line buffering, while values of 2 or higher use a buffer of the specified size in bytes. In general, the default value is sufficient because the OS efficiently handles caching, but adjusting this parameter can be effective for very large files or special devices. The standard PathLab module makes path handling more intuitive. It improves readability and safety compared to string paths. This code demonstrates creating a directory with PathLab, writing to a text file, and reading its contents. With a path object, you can handle paths both intuitively and safely. Path has convenient APIs such as iter directory and glob. You can write code without worrying about path separators between different operating systems. Temporary files can be created safely with TempFile. This avoids security race conditions and name collisions. The following code shows an example of creating temporary data using a temporary file. This code creates a temporary file, writes and reads data, and deletes it automatically when the with block ends. Using TempFile, named temporary file, you can handle temporary files safely and without conflicts. Because delete equals true is specified, the file is deleted automatically. On Windows, you may not be able to open the file from another handle immediately, so you can set delete equals false and manage deletion yourself. Recursive copying, moving, and deleting of files and directories is easy with ShellUtil. ShellUtil copy 2 inches also copies metadata, such as modification time. Move will fall back to moving the file even if rename cannot be used. Remove tree is a dangerous operation, so always confirm and back up before deleting. File size, modification time, and permissions can be read and modified with OS and stat. The following code obtains basic file information with OS stat and changes permissions with OS change mode. Permissions behave differently on POSIX and Windows systems. If cross-platform compatibility is important, use high-level APIs or add conditional handling. Exclusive control is needed when multiple processes access the same file in parallel. Unix uses fcontrol, and Windows uses MSVCRT. The following code uses fcontrol flock on Unix systems to acquire an exclusive lock when writing. This code acquires an exclusive lock using fcontrol flock on Unix-like systems to safely write and prevent simultaneous writes to the file. Always release the lock after processing to allow access by other processes. On Windows, use MSVCRT locking. For higher-level usage, consider external libraries such as Portalocker or FileLock. To prevent file corruption during updates, write to a temporary file and replace it using OS replace on success. Writing to a temporary file and then replacing avoids corruption if a crash occurs. OS. Replace performs an atomic replacement within the same file system. Note that atomicity is not guaranteed across different mounts. For random access to large files, mmap improves I/O performance. It mainly involves binary operations. The following code memory maps a file and reads or writes specific byte ranges. Be careful when changing the file size. This code maps a binary file to memory with mmap and performs direct byte-level read-write operations. Memory mapping enables fast random access to large datasets. mmap is efficient, but incorrect use may lead to data consistency issues. Call flush to synchronize as needed. Specific data formats have dedicated modules. Use CSV for CSV, JSON for JSON, and Pickle for saving Python objects. The following code gives basic examples of reading and writing CSV and JSON, and using Pickle. Since Pickle can execute arbitrary code, avoid loading data from untrusted sources. Specifying newline equals for CSV is recommended to prevent extra blank lines on Windows. With ensure_ASCII equals false, JSON keeps UTF-8 characters readable. Directly handling gzip and zip can save disk space. The standard library includes corresponding modules. The following code is a simple example of reading and writing gzip files as text. There is a trade-off between compression ratio and speed depending on the compression level and format. The following points can be considered for security and vulnerability measures. Do not use untrusted input directly in file names or paths. Use Pickle only with trusted sources. Minimize execution privileges, and give only the minimum permissions to processes handling files. Use temporary files with temp file, and do not store plain files in public directories. If using user input in file paths, normalization and validation are required. For example, use path, resolve, and check parent directories. Be especially careful when using external input as file paths in web apps or public APIs. For file operations, it is important to use safe and reliable techniques such as using the with statement, explicitly specifying encoding and atomic writes. For large-scale processing or parallel access, it is necessary to implement locking and log management systems to prevent data corruption and conflicts. Balancing efficiency and safety is the key to reliable file operations. The source code for this video can be downloaded from the official website. If you like, please visit the URL in the description to aid your learning. Thank you for watching. This channel provides practical and useful information about programming. Subscribe to the channel and let's deepen our programming skills together.